Hi, I'm Zach Shelby, co-founder and CEO of Edge Impulse. Welcome to our new episode of Machine Learning on the Edge, where we look at how data and machine learning are having a huge impact on industries thanks to the latest advancements in AI and edge compute. Today, I'm really happy to have Guido Jouret on the show with me.
Hi, Zach.
Welcome. Guido's had an incredible career, longtime Cisco innovation and IoT leader, more recently Chief Digital Officer at ABB, on the board of Polycom, and advising lots of amazing startups and VC investors.
Correct.
So I want to dive into IoT. We both came from the space of IoT innovation almost a decade ago. I just looked back at the date, 2013. We were just coming out the end of kind of early IoT adoption. I was at SensiNode, just working on electric meters, street lighting, enterprise scale, wide area networks. And then we were acquired by ARM. At the same time, Cisco is investing big in IoT. Where has IoT come since then?
I think there's really sort of two IoT markets that have emerged. One is the consumer side, and we know this through the connected home speakers, the smart light bulbs. You can change the colors and things like this. And sadly enough, there's been a proliferation in the consumer side, but no real compelling use case. So it's entertaining to be able to do that, but it's not changing your life. On the industrial side, there's a lot more that is yet to come still in the IoT space, right? So smart meters you mentioned, we're going to see more and more autonomous vehicles, we're going to see more and more innovations in the healthcare sector, for example, wellness all the way towards patient care. And that's still sort of a work in progress, but it's one of the reasons why the progress has been slower, I suspect, than both of us may have wanted, is that it's a really hard problem. You have to connect things, get the data, compute on the data, interpret the data, and take action. And we're probably going to dig into this some more, but it's a really hard problem, but a very worthwhile problem to solve.
And that brings me back to those technology challenges of IoT. We worried a lot about data collection, connectivity. Is it 802.15.4G or E or Z? I don't remember anymore. Mm-hmm. And it feels like we've solved that problem, right? I don't worry about it. Just thinking about this, when we're engineering things today, I don't really worry about connectivity as much any longer. We have so many things in our toolkit that just work.
Yes.
When we're starting to apply data now, I think that's where things get interesting, right? We talk about machine learning enabling and data-driven engineering. I like to think of it as a revolution in these industries. How is that now complementing IoT? And what are some of the challenges we're seeing as well? Opportunities and challenges in applying data in these industries?
Well, one of the things that's happened is I think we've seen a dramatic drop in connectivity cost, right? So as you said, if you want to get connected, you can get connected, right? Wi-Fi, Bluetooth, Zigbee, satellite connectivity, 5G, take your pick. Secondly, compute, the Raspberry Pi, the ARM processor at the edge, a lot more processing power than we would have dreamed of even a short while ago. Then we have also this issue around, okay, now that we're getting this data, the sensors themselves are getting very, very good. Like just think of cameras and how good the camera in your smartphone has become over the past couple of years. You want more than one camera? No problem, right? So our ability to generate the data has increased dramatically. And we also have software innovations, so container technologies, virtualization, computing in the cloud. So there's a lot more that's enabled programmers to now deal with this data. But the ultimate question still remains, which is, okay, now that you're facing this tsunami of data coming from the edge about the physical world, how do you turn that into viable and useful outcomes and predictions?
Yeah, so it's about this turning data into expert knowledge, or turning the expert knowledge into data, into algorithms that can solve valuable problems.
Right.
And I like that chain of thought that we've solved these other areas of technology. Now let's go apply the data to unlock new things. But what are the challenging sides of it? I mean, as engineers, we see the upside always. All right, let's apply some deep learning to this new computer vision application. We're going to unlock this new value in, say, manufacturing. What's the downside of the technology? Because for me, something I struggle with as an engineer is like, this is all probabilistic. And when you understand machine learning deeply enough, you can come to terms with the probabilistic nature. You can apply that to solve problems in safe ways. But the rest of the engineering world is still far behind that. Like, what do we have to do to solve that gap?
So one of the things we have to recognize is what are the limitations of the machine learning technologies that are available today? So one is, of course, that a machine learning model is a black box, right? You put a whole bunch of inputs together, you train it on the desired outputs, and you try to fit the model that you want. But ultimately, you're still left, especially with mission critical health and safety, sort of really important kind of automation jobs, you're still struggling with the idea, well, how will this behave at the boundary conditions? What if I present it with some data or a condition that was not in my training set? If it's just a technology that you use to generate some pretty pictures on, say, Midjourney or some other application, you get something that looks like it was cooked in the microwave. Okay, not a big problem. But if this is now controlling a vessel or somebody's insulin pump, or it's being used to control the energy in a factory, the repercussions could be pretty severe. So there's been this tension between, gosh, we like the predictability of traditional automation, which is rule-based, but those kind of systems can't cope with the complexity of multidimensional real-world problems very well. And so now it's like, how do I know how this will behave? If it does produce a weird output, how can I have it explain itself? Like, how did it come up with this output, right? You can't just dump a bunch of weights on the table and say, well, these are the weights, right? Ideally, you want to be able to sort of say, walk me through your reasoning so I can understand where things went wrong.
So the decomposability of models could be one of the holy grails we've got, understanding what are the steps in order for the model to make that decision. But also maybe the boundary conditions. I like when we've talked in the past about physics-based models. Are we kind of going towards a world of hybrids and boundary conditions?
It's a fascinating idea because there's a talk more and more in the ML space around synthetic data to use to train these machine learning models. And if you have physics models, which we quite often do in a lot of areas in the industrial space, like if you have an electrical transformer, the physics of how that performs with certain current loads and temperatures is well understood. So you could use the physics models to create synthetic data to start the training. You could also use that, I think you were calling it earlier, sort of a wrapper around the model to potentially know when the model might not be producing a sensible output, because you know that this prediction or this particular outcome doesn't fit the model. As you said, composability, because one of the reasons we want to go to ML is because the real world is so multidimensional and so complex. So the physics models by themselves will not get us there. We also need to be able to insert the human in the loop. So when the model has a low confidence prediction, it says like, okay, I'll give you an outcome, but I didn't have a lot of training data in this. So therefore, take this, caveat emptor, take this with a grain of salt. How do we seamlessly then transition to a human operator who can take over and ideally teach the model to say, next time this happens, do it like that.
And we have even techniques like anomaly detection using classical ML technologies, which can kind of balance deep neural networks, which get very confused. When you have something that happens outside of the training scope, neural networks will go, oh yeah, that was a left. Even though it was like a straight up, right? That it's never seen before, right? A rocket ship took off and now this autonomous vehicle is going, I don't know what happened, but I think that was a left. Mm-hmm. And that's because neural networks can't understand and infer what happened outside of their training sets. Yes. But classical ML techniques around anomaly detection can. They can actually tell when you're going away from your training set. Mm-hmm. So sometimes we can even build boundary models of different techniques. And we shouldn't ever just think about machine learning as deep learning because of that. Complement techniques to try to create those boundaries. But I do like that idea of like building boundary boxes around models for safety, but also for predictability. Mm-hmm. And then always keeping that human in the loop. I don't think we're anywhere near an AI future that people dream about in sci-fi where this is completely autonomous. We do have to have humans helping make the decisions. Yes. And ML produces valuable predictions for us. And Guido, you had a fascinating time at ABB, leading digital transformation, getting to deploy the platforms and the technologies that engineers use to solve real problems. and across so many spaces, robotics, process control, energy. What were some of the use cases that stuck in your mind where ML was being applied or is going to be applied in the future?
So thanks. Especially in the robotics area, that I think a lot of people would naturally understand. It's all about adding vision systems, allowing robots to collaboratively work with humans, also making it easier to program robots. So today you program robots by telling how the arm should move. In the future, you can say, this is what success looks like, you figure it out. So that's the future of making robots more accessible, more suitable. In the area of electrical control, ABB makes a smart circuit breaker that can optimize the load and the management of energy behind the meter. So it creates a microgrid, integrating energy generation, maybe solar panels on the roof, along with batteries inside the building. So maybe you have a fleet of electric trucks, they need to be charged, but you need to figure out based on electricity costs, future loads. So you're optimizing for multiple dimensions. So there's an intelligent system that predicts that. And then in terms of the areas of process control, everything from optimizing the extraction of oil from the seabed and trying to optimize the overall mix of ingredients to maximize output. So you're trying to get for maximum efficiency, whether that's in pharmaceuticals, making fertilizer, or in basic food and beverage type applications as well.
Amazing breadth of applications, like we're seeing also in electric transformer tuning. So when we get into the personalization of equipment, I also think this is a kind of holy grail of machine learning where we can use layers of data, the base models, but then we can start to layer on the customization per machine and per deployment.
Yes.
And in so many applications, also in electric motors, we have a lot of this tuning that has to go on by hand in the field. That's something we can add a lot of value, save a lot of money in optimizing these things and think about personalized machine learning. Another area that I really love in the application of data and machine learning algorithms is digital health. We started working with Aura Health, the smart ring company, years ago in helping really use data to drive lots of new algorithm development, a lot of new innovation, and try to bring the traditional algorithm development life cycles down from years to months and really bring in new ways of thinking about innovation in the space. And I've noticed you've done a lot of work in digital health, medical, pharma. How do you see this evolution of machine learning and data being applied in this space? And do we eventually get to medical devices as well?
I think that in terms of IoT, health and wellness is probably the biggest potential market for IoT of all. Here in the United States, healthcare is already 19% of GDP. We spend almost more than double what most OECD countries spend on health. And what we thought about when I was at Nokia investing in this area, our team got together and said, how do we look at this market? And we thought of it in terms of at least two, but there's probably a third market I want to talk about in between as well. So the first market is really what we call the worried well. So how do we help keep you fit? Because instead of making you waiting until you get sick, how do we make sure that you stay healthy? So the Oura Ring is an example of that. So sleep, activity, mood, there are a lot of different things you can infer. And how do we use the data that we have from those devices to nudge you into good behaviors? So that's the first problem. Then at the other extreme, you have remote patient care. So devices that are monitoring stroke victims, for example, or inside the hospital, looking at the patient's EKG and temperature and heart rate. And that is all about trying to provide continuous data and feedback on treatments that are working and how well they're working. But I believe there's a giant market in between, which we can go into as well, that could be sort of a stepping stone. How do we go from the unregulated or lightly regulated wellness market towards this sort of much more difficult and challenging medical market? A lot of people see that as a binary thing, and I actually think that it's a continuum.
Yeah, and we've talked about these kind of alternative markets that come in between. Like, I'm already seeing machine learning applications on the very beginning of medical devices. Yeah. And so passive monitoring, right, of things like glucose. There's so much that we can do and that are within limits of what the FDA will let us do today. And then there's whole areas of medical that are still pretty much off limits because the FDA hasn't really decided what it thinks about machine learning. It's kind of left as an open question at the moment.
Right.
And so there's a lot of hesitation there to apply machine learning. But what other markets can we go after in the meantime?
So I think the things that can be done that are in between is, so one area is the whole pet care market. So for dogs, cats, cows, there's a whole bunch of applications there where the hurdle of proof and the regulatory framework is not as severe, understandably, as it is when you're experimenting on people. There's another market where you're not experimenting on people, but where you can apply the same wellness technologies to actually affect a much more important outcome, I think, which is to take care of the elderly. So when elderly, most of the time you ask them, hey, how do you want to live your golden years? They don't want to be living in an assisted care facility. They ideally want to stay in their homes. But the people that look after them or that care about them, they worry. And they worry because they say, what if you fall down? What if you're not getting enough activity? So a lot of these technologies developed for the wellness market with different algorithms can detect, for example, a difference in lifestyle. You're getting up later. You're not moving around as much. Your gait has changed. So how you walk has started to change. And doctors have correlated the degradation in gait to life expectancy limitations and all the rest. So there's a lot of really interesting applications of that technology that can be put in place to allow people to age better in place and to enjoy their golden years.
And a lot of what we've been talking about, those innovations, this new application of machine learning and data and IoT, these are going to be driven by startups. I'm an entrepreneur. I've always been really interested in supporting startup entrepreneurs in their journey to bring innovations to market. You've been on both sides, right? Innovating internally, like in Cisco, acquiring companies like YThings, and then now on the VC and advisory side. The market's a mess at the moment, right? We hear a lot of potential startup founders are scared away by that, but I actually get quite excited. I think that, wow, this is the time to go invest in the new thing. You've got a couple of years to go do this in kind of peace while everybody else is distracted, and go build the next big thing. How do you encourage the next generation of startup entrepreneurs now to go take advantage of the current market, and what kind of products should they be building in IoT and machine learning? Where does it make sense to go succeed?
So I look at it in terms of supply and demand side. So all of a sudden, this crisis, the economic recessions that's happening, is a boon on the supply side, because although people are hit by layoffs, and of course a lot of companies are struggling to come up with cash, if you do have the resources, i.e. the cash, finding good talent has all of a sudden become a lot easier. So all of a sudden, people who might not have considered working at a startup maybe don't have a choice, or they're saying, you know what, that sounds pretty good right now. So that's great for you. Also, things like real estate has now become cheaper because buildings are lying empty. So I think that creates great sort of possibility of supply. On the demand side, what recessions and important events like this tend to do is they cause a mindset shift. So basically, people think differently about doing something in a way that maybe they hadn't thought of before. So during the pandemic, people working from home, people had said, no, that'll never work. And yet, in the case of, say, telemedicine adoption now, post-pandemic, is 40 times what it was pre-pandemic. So all of a sudden, there's this huge shift in an acceptance of something. And when that happens, that creates demand. So for a startup, you have supply and you have demand, and these tectonic shifts that happen like in moments like these are usually when the next great companies are born.
And that matches my experience directly. I mean, I lived through the 2008, 2009 financial crisis as a startup founder and came out stronger on the other side. Almost died in between. It was pretty traumatic, but came out the other side and found that, wow, when you really were able to solve the important problems and go build the right product during the recession, when the market heated up on the upside of it, in this case 2010, 11, that's when the magic really happens. So for all of you startup entrepreneurs, this is a great time to be building in IoT and data and machine learning, solving the right problems. And that's actually one final thing I want to talk about is vertical versus horizontal. I see a lot of startup entrepreneurs coming in and going like, all right, I'm going to build the platform for everybody. But building platforms is really hard, right? How do you think about vertical versus horizontal?
So I have a bit of a contrarian view to this, which is that although everybody says building the picks and shovels that everybody else is going to use is where you want to be, the problem is that in the absence of a market, nobody's buying the picks and shovels. So give an example. So virtualization technology. We're here in the Computer History Museum. IBM was one of the first pioneers with virtualization technology in the 3090 mainframe. But essentially, that technology has been transposed to PCs. You can now virtualize, get containers, virtual machines. So you might say, gee, why didn't we use that technology from the beginning of the PC era? Because we had this one app, one PC, and gosh, that PC was running at 10% utilization. We have 10 of these PCs, we could run all these apps on one. Yeah, however, it wasn't until you had a proliferation of applications that you realized you had an opportunity for a horizontal platform. And so it's almost like you need to let 1,000 flowers bloom. And I also think that oftentimes, the first use of a technology is not ultimately what it gets used for. So as a result, if you try to build a horizontal platform without strong demand, you might go nowhere because nobody has this problem. And it's only once you have many, many people trying to do something that you end up recognizing, oh, we could refactor this and create a common layer here. We could have a common database. We could have a common set of middleware. And it's only in hindsight that we see the value in that platform.
AWS.
Yes.
Maybe the best example in the history of the planet. Amazon realizing that, wow, we're sitting on these extremely valuable microservices running on all this infrastructure. We could monetize this. And so, yeah, go build the vertical application, go solve the real problem, and then there's a lot of business to be had. Guido, thank you.
Thank you very much, Zach.
I really enjoyed diving into the world of industrial and digital health. Amazing to hear the market opportunity that awaits us. And thanks to all of you for joining us on this month's episode of Machine Learning on the Edge. Welcome back next month to hear more about what's happening with data-driven engineering, machine learning, and edge compute. See you then.